Okay, now I want to revisit one of the problems that we did on the combination permutation work from last week. One of the questions on that activity was, in how many different ways can the letters in the word Illinois be arranged to make a new word? And remember, our definition of word here is pretty loose. We're talking about arrangements of letters. Okay, so it should be, I think, pretty obvious to everyone. There are 8 letters here, and if we just lined them all up, then and asked, like we've been asking about the runners or whoever else, how many choices do I have for the first letter? Well, there are 8 choices, 8 letters I could put in here. Then there are 7 after that, and then it walks down the line from here. So we can start out saying that the number of possible arrangements of the letters in Illinois is 8 factorial. Okay, but then we come to kind of the sticky situation of if we had, like, I'm just going to line up the 3 I's, then the 2 L's, and then the leftovers, what I'd have N-O-S. So when it comes right down to it, it doesn't really matter what order these 3 I's are in. So we want to, do you see it doesn't matter if this I comes first or if this I comes first? So what we've done in this 8 factorial is we've included the orderings of these 3 I's. And so we want to take those orderings out. So if we want to take those orderings out, then we want to remove the number of ways we can order the 3 I's. And the number of ways we can order 3 I's is 3 times 2 times 1, or 3 factorial. That would remove the orderings of the I's. We'd also want to remove the orderings of the L's. There are only 2 of these. So we're going to remove 2 times 1 orderings of L's. And then, obviously, these guys are all singles. So our final answer is 8 factorial divided by 3 factorial times 2 factorial. So in short, if we're looking at a permutation with repetition, these letters are repeated, then we're going to look at n factorial, but then we've got to divide out all of the cases where the letters were repeated. Hey, if you'll recall, the question just before Illinois was a question about Jordan. And if you'll look at this word has no repeated letters. And so the number of ways we can order the letters in the word Jordan is 6 factorial, nothing else. It's just 6 factorial because we don't have to remove any orderings. So, hey, let's consider Mississippi. Pause the video. Calculate how many different ways you can order the letters in the word Mississippi. And when you come back, we'll have an answer. Okay, so we count up the number of letters in the word. There are, can't count, there are 11. So we're going to write down 11 factorial, but then we have to remove the permutations of the repeated letters. I'm sorry, we have to remove the orderings of the repeated letters. So the first letter I notice that's repeated is the S's. And so to remove the ordering of those S's, we're going to divide by 4 factorial because there are 4 of them. Then I'm going to look at the I's. That's another divide by 4 factorial. Then we repeat the P's twice, two P's. So we're going to divide that by 2 factorial. So the result of this division here is the number of different orderings in the word Mississippi. One more. This will carry over to our next video. How about the word boo-boo? Okay, some would argue this word should be hyphenated, but let's go with it. How many different orderings of the word, how many different orderings of the letters in the word boo-boo do we have? Pause the video. Okay, and then real quickly, we've got 6 choices of letters, but then we have to divide out the orderings of the O's, that would be 4 factorial, and then the orderings of the B's, that would be 2 factorial. And the result of this is the number of ways we can order the letters in boo-boo.